Hey, welcome back. We're still on the subject of eutrophication, and we kind of went over what eutrophication wasn't for a while, and then the important nutrients and where those came from, and why it's really taken off in the last 150 years. Now, let's look at what eutrophication does to a system. Okay, this will give you an idea of where, how we've changed the important fluxes in our atmosphere that really control eutrophication and how that's changed the water systems and terrestrial systems. Now, if you look at the fixation of nitrogen, again, an important component of eutrophication, there are natural ways that nitrogen is fixed. There are legumes and bacteria that do it naturally, so they're able to bring in atmospheric nitrogen and fix it to a form that plants can use. Even lightning fixes nitrogen. But we came along, we invented the HaberBosch process, and we were able to change tons of atmospheric nitrogen into a form that plants can use for fertilizer. Again, we did that to such an extent, we've basically doubled the amount of nitrogen that's fixed every year. And this HaberBosch process had a huge impact on society, because once you could increase the amount of nitrogen fertilizer you produced, you could also increase the population. And the other side effect of HaberBosch process is you could make gunpowder and blow everyone up. So wonderful. Again, we've doubled the flux into these systems. We also, as mentioned before, have another way that we add nitrogen straight into waterways, and that's through acid rain. So nitrogen gets added directly to streams and rivers in the ocean. And another way that acid rain is important is the acidity, and this could be from sulfur as well, out of power plants, can mobilize nutrients in soil besides nitrogen and phosphorus, and these other nutrients get in the system and cause eutrophication. Okay, the other big contributor, like we mentioned, was phosphorus. This shows this cartoon shows the flux of phosphorus in our environment, and generally for our fertilizer, our phosphorus fertilizer, we're getting it from guano on islands that was deposited by birds, and also breaking up rocks and extracting the phosphorus that way. And that's worked for a long time, but again, leaching has put these things into our waterways, and eutrophication has increased. Another thing that's interesting is there's some evidence that peak phosphorus might be occurring, just like peak oil. And you can think of it, if we're mining out of rocks, it's really dependent on fossil fuels, and that might be one of the reasons why these things are occurring at a similar moment. Okay. So again, acid rain directly into systems, and also mobilizing those nutrients. Okay, and what's the net result? Again, algae growth. You can see this in waterways in central New York. We used to have a camp on Oneida Lake, and this is generally what the water looked like in the fall. And in extreme cases, you get systems looking like this, and you can imagine some of the negative consequences. So the other thing that occurs is, besides the algae, macrophytes on the bottom and the sides of these systems grow like crazy as well. Okay, so the effects of eutrophication. Plant growth promotes algal growth. You get more zooplankton. And in the end, more fish often, which can be a good thing. But often they're not the same species because you dramatically change the system. Okay, this is, this brown trout. We love this. This is what we want. But with even more eutrophication, you get systems that are really in tough shape. So what can occur with even more eutrophication? One is these huge blooms of algae and cyanobacteria, and straight because of the algae, you get a change in oxygen levels. But once the algae dies, goes to the bottom and is decomposed by bacteria, even more oxygen is used up. And in some of these systems near the bottom, you can get close to 0 parts per million oxygen levels, which kills all fish around the area. Okay, so as a result, zooplankton and fish suffocate or are poisoned by toxins released by the algae and cyanobacteria, and we'll get into a specific case of this occurring. Okay, and side effects, water has a foul taste. I grew up in Rochester. Every fall, the water would start to taste really different, so that's another side effect. Okay, and just kind of to review graphically, you have your normal stream flow, normal fluxes in nitrogen, carbon dioxide, and oxygen. You got all the living critters here. In the case of phosphorus, once that increases, you start to get the algae. It's also blocking light, which can have an impact on the system. And eventually, sediment buildup, algae decomposing, and oxygen being used up, death of organisms in the system. Okay, so we're going to stop there and talk a little bit about some really extreme cases and potential for human health effects as well. So I'll see you next time.